So now it's my turn. Hope you already enjoyed your dessert and coffee. And thanks for Hosoya-san's layout the basic knowledge of biodiversity informatics. So I will, based on his talk, to go a little bit deeper. Sorry. Okay, so I will introduce the data standard and the data license for sharing or publishing biodiversity data. So why we have to share or publish the biodiversity data? As Hosoya-san mentioned, we rely on biodiversity, right? So biodiversity provides a lot of ecosystem services. So it's very important for our daily living. But now, because of the environmental change and the economic development, cause a lot of national, regional, and global issues. That's cause land use or land cover changes and climate changes and result in loss in habitat and biodiversity and ecosystem service. So to resolve these issues, there are a lot of international government work on this. But all of this based on the data, right? Without data, we cannot get correct information to assess the current situation or status of biodiversity, and we need science-based knowledge to make policy and this decision to resolve all these issues. So data is the most basic layer in the whole globe to resolve the whole global issues. Right? And in context of GBIF, GBIF provides open data, biodiversity data, and also promotes reuse open biodiversity data. So in next 4 years, we will focus on. Now, currently, it's already deliver relevant biodiversity data, and we will continue to work on improving data qualities. But as previous talk shows, there's some data gap, especially in our Asian regions, right? So we're using this open data to organize the biodiversity knowledges, and also through the collaboration of networks, we can empower the global networks. So look at if you go to the GBIF data portal, you can see the global, currently the current distribution records globally. But if we run into our Asian region, there's a lot of data gap, right? Although Taiwan have 1.6 million, but I think the great issue is the data qualities. We already aware of that. So for our own case, we have to encourage the more researchers and the students. They are willing to open their data set and even improve the data quality. So we can, based on this, to make more accurate decision and policies. But if you can go to GBIF website, data by countries. So I look up this, for example, here list Southeast Asia countries. There are some data sets and some current records, but you see there's no checklist being published to GBIF. But checklist is the most basic thing about the biodiversity of a country. So I think without this, it will cause a lot of issues. For example, when you count how many species, you don't have a national checklist how many species in your country. You cannot accurately know, right? And also for compiling, when you're preparing a document of local biodiversity, or somebody collected the name of the species, or in herbariums or museum, they digitize the name. But without a national checklist, the scientific name have been corrected. Maybe many input error, typos will cause a lot of wrong name or invalid name. So that maybe cause a wrong estimates of biodiversity. So a lot of issues. So the most basic important things checklist for each countries, right? And although all these occurrence data probably contributed by other countries, they make a field survey and repatriate the data to GBIF to other countries through GBIF mediate. And for example, in Taiwan's case, GBIF also make a country report every year for every country. Even the country is not a member of GBIF, they still have a country report. So you can, through this country report, you can see the current status of your countries, how many species, how many records in different categories of organisms. So you can go to the GBIF web portal to check the current status. If the information is not correct, please contribute your data to GBIF to correct the information. So currently GBIF have been established since 2001. Now it's over almost 15 years and mobilize the biodiversity data sets and index mobilize the data sets into a global data portal. So that these data can be searchable and downloadable. Right? So all these data can be used for niche modeling or estimate the biodiversity issues in each places. Right? So the next step, the goal is try to well organize all this data as evidence for species occurrence. And in the future, maybe can form a global network of virtual museum. So through GBIF media's the occurrence data, checklist, and sampling event data, so people can access the all informations of a species through internet. It's all open data. So that's the future dream. So without share or published data, all this dream is not achievable. So data, why? You may ask, why should we open our data or share our data? Because data produced using public fund, right? Who using your own money to do research to collect the data. If you do that way, maybe you have reason don't open your data. But I think most of the researchers get the funding support from government, and the government money is from taxpayer. So in other words, the data should be a common good, right? It's public assets. It should be open. And also open the data freely available on the internet, easily download, so easily for inspection, interpretation, and reuse by other people, the third party. So it also will increase the value of the data. And also, if we open the data, it will increase the transparency and overall quality of science, because everyone can check the data is there any errors there, right? And published data can be cited, reused in the future. And open data can be integrated with other data sets across space and time, especially when we want to evaluate the potential threat of a species. We need the past and current and to predict the future. So all these are good reasons to open data. Also, data integration. For example, I open my data and you also open your data, and somebody may need the data. And from the internet, they can search and know who has the data. So that will increase the recognition in the web, on the web, and also can promote the collaboration in international or regional collaborations. Right? And also, open data can increase the potential interdisciplinary research. Currently, we just only do our biodiversity research, but maybe some other research field, they're also concerned about the economic value of biodiversity or ecosystem services. They will use these data. And also some other social and cultural research, they will use biodiversity data. And also, when we share the data, we don't have to do the same thing in the same place, in the same time, right? We can share the data sets, so that will reduce or avoid the duplication in data collecting effort and reduce the cost. And also, published data can be indexed and made discoverable, browsable, searchable on the internet. It's quite convenient, so that will facilitate the data integration and reuse. And collection managers can trace the usage of citation of digitized data. So currently for museum, I don't know how the situation in each country is. Many people visit museums, so you will count how many people, how many visitors to your museum each year, right? That's some kind of a key performance indicator to evaluate the value of your institution. But if you can digitize the data and let the data open on the internet and make it open access, so you can count how many access for the data set, right? So that if the data sets are quite often being downloaded or used, that shows the high value of the data set and also shows a high contribution from your institution. Okay, and also the most important is when we publish the data set, we get the funding support from some governmental agencies or some private sectors, and also they can be credited. Right? Without this funding support, we cannot collect the data. And also the data set and the metadata. Later we mentioned what is metadata and related. And when we publish the data associated with metadata and the data paper, so it can be linked together. That means we will preserve the complete information about the data, so make the data reusable and more valuable in the futures. Okay, so the ultimate goal is that the all open data linked together on the web, so we can easily integrate the knowledge from the data on the web. So all these reasons are why we have to open the data. And also for scholar research, we cite paper, right? We cite research paper. But in the future, we should also think about through data sharing, we should and reuse the data in biology. We also should consider the co-authorship because their contribution from their contribution of the data. And also, recent years, there are some researchers advocates that we should not say data sharing. We should just open the data because data sharing is just like some how to say, I'm willing to share. It's not responsibility, but open data is actually our responsibility because it's the public money to generate the data. Right? So when we get the data, maybe we think how to use the data. I can make a metaphor. Like data is kind of data product. Just like you buy some product, maybe you get a package, beautiful package, right? But how beautiful is not important. The most important is the content. Did the product provide you a user manual so you can quickly know how to use this product? And did the package provide you a specification so you know the quality of your product? So if we think data is a product, and also provide a user manual and specification so you can understand how to use this product, right? So to facilitate reuse and increase the value of this product or packages. So if you want to, Shao says data set. Here I introduce another data package. Data package is more, how to say, precise words to describe the data and associate content with the data, and also describe the whole structures of the data. So it's a coherent collection of data and possibly other data assets in a single packages. Okay, so it's provide the basis for convenient delivery, installation, management of the data sets. So data sets should include metadata, and metadata is the description content about the data. For example, how, when, where, who collected the data, right? And the resources, sometimes if you visit the GBIF data portal, they're talking about the resources, not data sets, not data package. That's all these words are synonyms. Because why they call it resources? Because everything available on the internet is kind of resource. Data package or data set is also kind of resources. Okay, so the resources, that means the data files. For us, we're using Excel, right? Excel has many data tables. So data tables, Excel files is kind of resources. So we're using metadata to describe the resources. So how to describe the data sets is kind of art. Different people are using different titles for the column names, right? So that you may say is art. But sometimes, if you want to integrate the data, for example, your classmate, your colleagues give you a data set, but he named the title of each column is different from you. So if he or she did not provide you any information, so you have to ask him or her what's the title means, what's the unit for these values, what is the unit for these values. Such kind of things is cause a lot of problem because we don't have standard. Actually, we rely on standard in our daily life. For example, if you're using a remote controller, right? You see this icon, the icon on the button. So you see a square, it means stop. You see the triangle, right way is play, right? So this kind of standard. So how to describe the biodiversity in a standard way? So there must be some standard. Maybe we already use it, but we don't know that. Okay. So previously I mentioned there's a data package should include metadata, and another is resources data. So how to describe the metadata? So there's a standard called ecological metadata languages. It's just for describe the metadata. So you don't understand this, don't worry, just click the link, and if you want to know more, you can see the explanation. If you just want to stop here, it's okay, later I will show you the case. And the Darwin core terms, don't be frightened by these jargons, okay? It's just formalized or no reason why. It's just you use the terms they give you to describe this column. For example, a species, don't use, you want to put a column, a species name, don't use species, don't use some kind of other terms, just use scientific name. And the writing there have a standard weight. So later you can see the case. And also using these terms, specific term to describe the data table. Okay, the column name for the data table, and also the structure. Maybe sometimes we get the complex data, we will separate the data into different tables. But how to link or aggregate the relationships between tables. Okay, so there is a standard ways to describe the biodiversity data if we adopt the Darwin core terms. Okay, so what is metadata? As I said, metadata just like a menu or specification of data of a product. You can think data is a data product. So there's give you some, if you read the menu, give you some section, right? And each section there is some detailed description about the function of or if something wrong, who should you contact with, something like this. So the most important, for example, I published a sampling event data set on GBIF, so you can find there is EML, so you can download the EML file. So the whole EML file is the description about the data set. But we don't aware that because this is for machine, such kind of standards for the communication between machine. But we human beings just read this kind of layout, right? So you don't have to worry about that. And also there is some information about the contact. If the product is malfunction, who should I contact with? So there is contact email and phone, so you can contact with these guys, right? So it's all about metadata. So this kind of is like EML, right? So you can see the content here. For example, is the name, who create these resources, this data. So you can find similar content here. This is my name, right? The creator. Creator is the who create these packages. So this is called EML structure. Actually, we're using web browser to browse web contents and show you the beautiful web pages. That's we see, because the computer already processed this kind of things into a beautiful layout, right? But behind is there is standard working there. So for data exchange, so machine must understand the structures based on some kind of standard. So it's kind of standard. And also the Darwin code terms. Currently, I will not talk too much, because the following days we will use this quite often, using hands-on exercise. But if you want to know more, you can just click the link. And for example, there are three main categories, terms or to describe biodiversity. For example, the taxon is just using this term to describe the checklist. And the occurrence, there's specific terms to describe the occurrence of species. There's where, when, how, right? And what kind of species. And another main category is sampling event. How this occurrence was acquired, through what kind of measurement or method. So these things, detailed things, can be described using sampling event terms. And we know biodiversity is very complex. So only these terms cannot describe all phases of biodiversity. So we can, they provide other extensions. If you are interested about this extension, you can visit the link. Some people may ask, how about if I have DNA data, if I have the gel image, can I describe? Yes, there is some extension here to describe the DNA data related to sample material in occurrence records. So, for example, here is the terms. For example, these terms can be used to describe a sampling event. The most important event is something happened in somewhere and sometime, right? An event have an event ID and the event state. So for us, if we do a field survey about biodiversity, so maybe we will set a sampling plot of what is the habitat of the plot. How we sampling this plot is a sampling protocol, and how large the sample plot is, the size value. What is the unit? Is square meter or square feet? So you can using this term to describe the all detailed thing about the sampling event and location. And georeference information, you can use the decimal latitude, decimal longitude, and the geodetic data, something like this. So there is already specific term here. Don't create new term by yourself. Okay, so these terms have specific meaning. So everyone follow this standard. So when we exchange data, we don't have to worry about how to align the data structure. Everything automatically can be done through the computer. Because computers say common language, just like we use, now we are communicating using English, right? And how about some measurement, environmental variables? If we, during the sampling process, we also do some environmental measurements. So there is also some terms. For example, previously the sampling event, right? I set a sample plot there. I do some environmental measurements in this plot. So these measurements have a measurement type. For example, the soil pH, right? And or something you can imagine. For example, the conductivity or water qualities. But all this related to a sampling event. So there can be connected through the event ID, right? And all measurements have their own value, and each measurement has an accuracy. and the unit, and who do the measurement, and when do the measurement. So all these things, and what kind of instrument or method applied to get this measurement. So all these things can be described using these terms. And also related to the sampling events, there must be some organisms appears in the plot. So how we describe the biodiversity occurrence, for example, the scientific name. Maybe some people will use species name, or some people using just using SP, right? But in the standard terms in Darwin core, we just using scientific name and use writing in this way. So that's called the standard way though. Okay, and also taxon ID, vernacular name. Vernacular name sometimes we use in common name, right? But in Darwin core usage, we have used vernacular name. So everyone uses the current title is this in this way. So data can be aggregate easily. And how about the data structure? How to aggregate or related data? Previously, we using event term to describe where I do the sampling, right? And what kind of protocol being applied to this sampling event. But there are some other information. For example, what kind of environmental variable we have measures. So there is another set of terms to describe these things. And these things are related because of there is an event ID can connect these two data tables together. And also another occurrence, right? So organism was sampled in the plot. So there is some terms can describe the species or amount of the individual of the species, something, and also related to the sampling events through the event ID. So through this, we can connect it different extensions, different table related to a sampling event. So this kind of a structure, we call this star schema. Star schema. Schema is just the structure of the data table, related data table. So in context of GBIF, we adopt the Darwin core terms, right? And these terms categorize into different core. For example, using sample event core, taxon core, occurrence core, measurement, effect extension, and all this information can be linked through ID. For example, in this case, we're using event ID to link different data tables. Okay, I show you this case here. We all familiar with this Excel spreadsheet, right? So normally we will organize our data table. There is 3 tables. For example, this upper one is sampling event, and this is measurement effect and occurrence. And 3 tables, if we align this, we're connected through the event ID. So you can see the sampling event here. There is some code to describe we use some term, some column to document the information. Date, sampling protocols, and the sampling value, size, unit, and habitat, right? And all this information can relate it to the measurement. For example, by using the GPS to measure the height of the sampling plot through the event ID, I can link this table to this event table. And another table is the occurrence of alien plants in the plot. So we also can use in the event ID to link to this plot, this event, okay, this sampling plot. So all these terms are used, standard Darwin core terms are used for standardized documentation of the occurrence records. Okay, so that's the open standard. Because GBIF provides open data, so all these ways of describing your data structure is open standards. So we adopt open standards so everyone can use the standard to exchange data. Okay. The next important thing is the data licensing. If you find some data set resources on the internet and you want to download, but somebody say, hey, no, you cannot download. You have to get some permission, you have to pay some fee or something else. There's a lot of frictions hampered there, so we cannot use the data easily. So that's caused a lot of problem to integrate the data, right? So open your mind is most important thing. So how to make the data can be reused freely, open data license is very important. Okay, to promote published open data, the three licensing was strongly encouraged. It's like open data common attribution license is ODC by. That means you waive all the rights about data. Even for people can freely use for commercial purpose, it's also possible. But yes, but people you worry about, they just using my data but don't acknowledge my data. I don't get any credit, right? And also the Creative Commons CC0 is also encourage you waive all your rights about the data. So that will promote the reuse the data. And also PDDL is some kind of the same thing. So if we adopt the open data license and when we publish the data, so let the data freely open on the internet so easily to get the data. So everyone, as Hososan mentioned, is the circle, right? This is a circle, and to increase our knowledge, to solve the whole global issues is very important. So the open definition is open means anyone can freely access, use, modify, and share for any purpose, right? That's really open, so you can use to anything. As I mentioned, why if they don't cite, but for scholar research, normally we cite paper, right? If I publish paper, I don't cite the paper, nobody will believe the result is true or something. Similar things, if I use data, but I don't cite the data source, maybe I fake the data. Nobody will believe that. So although we adopt the CC0, open data license, don't worry about it because you use the data, for example, I use the data from you, but I don't cite, nobody will believe me. My result is correct. So that means open license for data user doesn't mean you don't have to cite, right? And also when we publish the license, publish the data give open, we have to clearly give open data license. So people see this, they will know they can use this freely, but they also have to cite because it's the moral standard, right? And also when we publish the data on an open platform, so we can see the registration, everything can be indexed on the internet. So you publish paper, people will cite your paper. So your paper citation is high, it's called DCI. No, it's SCI, right? There's another citation index called DCI. How many times your data been cited, been used? And also when you publish the data, you get the DOI. So everything can be who used your data, no, not who used, how your data being used can be traced through the DOI because people will cite your data. And also, sorry. You see, when you publish the data, your institution also will get credit. So that shows the contribution of your institution to contribute the data to biodiversity, conservation and research. So that's why GBIF has so many data now, but it's still not enough because we know there's a lot of data gap and data quality issues in each country or each region. So how to use this data? So you can visit GBIF data portal to see you can explore currents, explore species or data set or something. If you want to know how to publish data, you can see these sections. But okay, anyway. So there is also shows the cases how to reuse the data. So what kind of result we can get by this integrated analysis from the freely available data sets. So that will contribute to conservation of biodiversity. Right? And also you can visit, if you use Mendeley reference management system, so you can, how to say, add GBIF public library to your Mendeley libraries. So you can know the latest status of who used the GBIF dataset, mediate dataset to publish new publication or new finding. So that will, how to say, overall it will increase our fundings in biodiversity and promote the international collaboration in biodiversity science. Okay, that's the whole talk. Thank you.